All right, so at the end of last class, we were talking about writing some shell scripts. And so we had this one shell script here. Right here. Come on. All right, there we go. Right, so we've got a shell script here. So remember, a shell script in bash, it always starts with this line here. Right, so either use that line. Again, if you're on Mac, use, if I get this right, user bin env bash. Or that on Mac, so that it actually finds your newly installed version of bash, as opposed to using your Mac OS version of bash, which is very old. This also works in Linux, so if you write that, that should be fine too in most Linux installations. So that first line there, that just tells the shell what program should be used to interpret this file. And so this says use bash to interpret this file. Right? And again, in the previous lecture, I showed you how to use Python or any other interpreter to interpret the contents of the file. Right? Bash comment, it's always a line ending comment, right? So it's the hashtag that indicates the start of the comment. Now I told you that if you ran this program, so let's run this program. Hopefully this works. It did work, okay. So when you run that program, you get no output. So it doesn't look like the program does anything, right? Because there is no significant lines of code in this script. But whenever you run a command in Linux, you always get an exit status of the command. So in fact, running this script does in fact produce a result. It just produces a result that you normally don't see. And so you end up with the exit status. Now the exit status of a command is stored in this funny, what's called a parameter called question mark. Okay. All right, and so this is a bit odd in bash. It's one of the weird things in bash. So bash says, this blue box right here, right? So bash says that a parameter is an entity that stores a value, right? So to most of us, that sounds like a variable, right? But bash, variables are parameters, but they're special types of parameters. So a variable in bash is a parameter that starts with a letter, right? So its name starts with a letter. Okay, so that kind of makes sense. That also implies that there must be other parameters, and there are. So bash has other parameters called the special parameters. Their names are symbols. And confusingly enough, some of the symbols overlap with some of the other special characters in the language. So that's a little confusing. That's just the way it is. So question mark is one of those special symbols. Right? So question mark is the name of a parameter that stores a value. It always stores the exit status of the most recently executed command. Then you have these things called the positional parameters. So the positional parameters, their names are all numbers. So 1, 2, 3, 4, 5, 6, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. And those I'll explain to you in a moment. Right? So you've got three types of parameters in bash. Right? You've got regular variables, which we'll use later on in the lecture, I think. We've got the special parameters, which are single symbols, which you'll see as we move through the course. And then there are the positional parameters, 0 through n, where n is an integer value. All right, so let's take a look at some other, okay. So remember a bash script? It's just lines of bash code, right? So here's the script, not a comments.shell, right? So all this does is it prints. So it echoes that string to the standard output, right? So echo takes its arguments and just writes those to standard output. Right? So if you run this script, right, not surprisingly, you get hashtag this is not a comment. Right? Okay, I'm going to skip over this. This is just explaining that comments in bash always end the line. Right? So if you wanted to, so here someone's trying to comment out just this part of the command. Right? That doesn't work in bash, right? Because the comment in bash always ends a line. So that just runs ls when you run that command. Right? So that's no big deal. All right, now what are these positional parameters? So the positional parameters correspond to the command line arguments. Right? So when you run a script, you're allowed to provide input to the script in the form of command line arguments. Right? So when I run cowsay, I can run cowsay hello. Right? Hello is the command line argument to the cowsay program. Right? Similarly, you can have command line arguments to your own script. Right? So the command line arguments, they're stored in the special, well, they're stored in the positional parameters 1, 2, 3, 4, 5, 6, 7, 8, and so on. Right? The number of arguments to your script, that's stored in the special parameter called hashtag. Right? So notice that the hashtag has a bunch of different meanings, right? It can be used as a comment, right? Hashtag exclamation mark, that's what is that? That's an interpreter directive, right? Now I'm telling you that hashtag on its own, that's actually a special parameter that stores the number of command line arguments that were given to a program. Right? The number 0 is a positional parameter. Right? So it stores the name of the path that was used to run your script. Okay? So to make that all clear, we've got a little script here called viewArgs. Right? So viewArgs, that views your command line arguments. So it lets you this particular script shows you up to 10 command line arguments. Right? And so all it does is it's just an echo command. Right? So there we go. All right, so echo, quote, right? Now what does quoting do? Quote suppresses all, suppresses all white space breaking, right? So in other words, if I write echo double quote and then I write a bunch of stuff, right? It's just going to print the bunch of stuff to the screen exactly the way you see it here, right? So inside the quoted argument, I've got this $hashtag, right? So remember, hashtag on its own, that's the number of arguments, command line arguments supplied to the script. If you want to get the value of hashtag in bash, you need the $sign in front of it. Right? So whenever you have a variable and you want the value of the variable, it's $variable name. Right? You might wonder why I have to slap the $sign in front. Right? So the reason you need the $sign in front is because bash just looks at strings. Right? So if you have a variable called s, right, and then you try to use s in an expression somehow, right, as far as bash is concerned, it's just a string. Right? So it doesn't actually know that you want the value of the variable stored in s. Right? So that's the significance of the $sign. Right? So the $sign indicates to bash that you want the value stored in a parameter. Right? Now, inside double quotes, right, you are allowed to access the value of a variable. Right? So in other words, inside double quotes, this accessing of a variable is not suppressed by the double quotes. Right? Remember, double quotes suppresses word, it suppresses word splitting and a bunch of other stuff. One of the things it does not suppress is that. Right? So inside double quotes, you can in fact get the value of a variable, right, and replace it, and replace that construct with whatever the value of hashtag is, right, the number of command line arguments. Right? On the next line, I'm going to write the value of $0. Right? So the value of $0 is the path name that was used to run the script. So I'll explain what that means in a second. Right? Notice that in front of it, I'm writing $$0. Right? So what does the backslash do? The backslash suppresses the special meaning of the $sign. Right? It's the escape character in bash. Right? So backslash $sign turns off, right, the special meaning of $sign. Right? So this prints $0 equals, and then whatever the path that you used to run the script was. Right? Next line, $1, that's the first command line argument, $2, second command line argument, $3, and so on. Right? If you have lots and lots and lots of command line arguments, so more than 9, right, then when you go to get the value of that command line argument, you have to write $brace 10, right, $brace 11, $brace 12, and so on and so on and so forth. Right? So now you need these braces to indicate that that thing 10 is actually the positional parameter 10 and not the numeric value, and not the positional parameter 1 followed by the string 0. Okay, so let's run this program, this script. Okay, so there it is in code, in Visual Studio Code. I'm just going to open up another terminal here and maximize that. Okay, so we're in the bash introduction to scripting, cd bash, yes, cd scripts, introduction, okay. All right, so there's view args over here, right? Okay, let's make this a little bigger for you. Okay, so dot view args, right? Again, remember I need the dot slash in front of view args because this directory is not on my path, right? So in other words, bash, bash doesn't know where to look for this executable program view args.sh, right? Because it's not on the path, so I have to tell it, look, the program I want to run is the view args.sh program that's in this directory, right? So dot slash. Okay, so if I just run it on its own, no command line arguments, right? This is what gets printed out, right? So no arguments, 0. How did I run the program? Well, I ran it as .viewArgs.sh, right? What's the first command line argument? Well, there's nothing. What's the second command line argument? There's nothing, and so on and so on and so forth, right? Notice that there's no error in this script, right? So in other words, that's not what I want. What's going on? Come on, go away. All right, so notice that, right? So $0, I'm accessing the value of $0, so that's fine. $0 is always set when you run a script. $1, that's supposed to be the first command line argument, but there are no command line arguments, right? So this looks like you're accessing a variable whose value hasn't been set, and so that is in fact what's happening. We are accessing a variable whose value hasn't been set. In bash, that's not an error, right? So remember that, in bash, that's not an error. If you access the value of a variable whose value hasn't been set, bash just considers that to be the empty string. It's never an error, right? So that's one thing you have to get used to, right? And so I'll talk more about that in the next notebook. But that's why this script doesn't fail with an error, right? So there's no $1, so bash just prints the empty string, right? There's no $2, bash just prints the empty string, and so on and so on and so forth. Okay, so let's run a different example. So .viewArgs. So ABC. Right. So now I've got one command line argument. Right. First command line argument, it's ABC. Everything else is the empty string. Right. And of course, if you run this with other strings, right, like that, right, you end up, those just get passed as separate command line variables. Separate command line arguments. Right. Okay, so how do you pass in a command line argument that actually has a space? Right, so suppose I really wanted to pass in a string with a space. Right, and I want to pass that in as a single command line argument. Well, the answer is quote it. Right? Why does quoting work? Because when you quote something, bash does not separate it into separate strings. Right? So you get one command line argument, and the value of that argument is a string with a space. Notice that the quotes, right? That quote is not part of the argument. Right? So in other words, bash discards that quote when you pass it into the, when bash discards the quote in the argument. Right? What else is there? Oh, right. What does that do? Right. So remember what star does, right? So star on its own matches every file name in your current directory, right? So when you expand this, right, that star is going to expand to every file name that's in my current directory. So when you run that, right, the first argument is comment.sh, second argument is cow.sh, right, and then fortunecow.sh, and so on and so on and so forth, right? There are more than 10 files in this directory, so there are in fact more command line arguments. It's just that this shell script is not using those arguments at all, right? Again, that's not an error. All right, any questions so far about the command line arguments? Yes? No. I can put in as many as I want. There is a maximum. I actually don't know what it is. So slash dollar brace, brace 11 equals dollar. Right, now I need the braces here. I'm going to show you what happens if I leave the braces off in a second. Oop, okay, like that. Right, so I can add in another one if I wanted to. Control L. Run the exact same command, and you're going to see 11 pops up, right? Okay. If you leave the brace off, something weird happens. Weird and unexpected, but it almost never happens because you almost never have this many command line arguments, right? So if I leave these braces off down here on 11, so I'm going to write $11, right? So notice that my Visual Studio Code is actually indicating that something funny is happening here because that second one is in a different color. All right, so if you do this and run the script, you get a funny result. Oops, wait, whoop. I get comment1, I get comment.sh1, right, which is very strange, right? So you look at this and you say, well, how did that happen, right? If you go back and look at $1, that's comment.sh, which just happens to be the same as what that is right there, right? Followed by a 1. Okay, so what's going on here, right? So when you use, when you're accessing the positional parameters, if you don't use the braces, bash assumes you want one of the positional parameters between 0 and 9. So here, I get positional parameter number 1, right? And then what gets printed? Well, whatever the value of the positional parameter 1 is, followed by the number 1, right? And so that's why you get comment.sh1. Right? Everything to bash is just a string, right? So $1, that's positional parameter 1, followed by the string 1. So it prints out the value of positional parameter 1, followed by 1. Yes?
So could you just link them, like $1, $2, $3,
Mm-hmm.
and you just get, I don't know, what was it, comment.sh, cow.sh, fortune cow.
Yeah. Sorry, what do you want to try to do?
Like you can just link them all together?
How do you link? What do you mean by linking them together?
Like instead of writing $1, you write $1, $2.
Yep. $2, $3. Right? So bash sees that, it says, well, what's $1? Well, it's whatever. It's command line argument number 1. What's $2? It's command line argument number 2. What's $3? It's command line argument 3. They're all just strings, just mash them together. Oh, wait, that's not what I want to do, sorry. Control S, okay. So run that. Right, comment.sh, cow.sh, fortune cow.sh, right? The value of the first, second, and third line command line, first, second, and third command line arguments all mashed together. Right. This is very weird if you come from a normal programming language like Python or Java, right? But this is the way it works in Bash. All right, any other questions about these command line arguments or getting the number of command line arguments? All right. Okay, so inside Jupyter Notebooks, there's no way to run a program and pass it command line arguments. So that doesn't work. I don't think it works anyway. I think I've tried it before. I don't think it works. Oh, sorry, I see, sorry. So there's no way for me to run a cell that contains a script and pass that cell command line arguments. That doesn't work. But I've saved all the scripts for you. And so if you know the path to the script, you can run the script with command line arguments inside a Jupyter Notebook, right? So here, this is how you'd run it from inside a Jupyter Notebook, right? You just need the path to the program. Oh, this is command line number 0. This is good. And then let me put in a command line argument. So hello. Right, so let me run that. Okay, so when I run that, $0, that's the name of the path that was used to run the script, right? So it's not always the name of the script, it's the path to the script, right? If you just wanted the name of the script, you have to do something else, right? You need to nuke everything in front of it somehow. Or you'd use another command. You'd use a bash command called base name would work as well. Right? Okay. So again, the notebook tells you down here, it's not considered an error to attempt to access the value of an argument or a parameter that's not set. Right? Again, that's also weird compared to other programming languages. Okay, and this just goes on and explains what the output of the program is if you actually try to run it. Right? Okay, now we've got command line arguments, right? So we know how to use these command line arguments. So I can take some of these other scripts that we had and now use command line arguments in those. Right? So let's take a look at some scripts that we had from the previous class. So we've got this script called hello, and hello just prints out hello. Right? It's not the most exciting script in the world. Right? So that script there just echoes hello world to the screen. Right? Not surprisingly, if I run it, sorry. Okay, if I run it, right, it prints out hello world. Right? Now that I've got command line arguments, I can add an extra, I can write the script so that it takes in a command line argument and it greets the user, for example. Right? So for example, there's a script called hello you that takes in a command line argument, and now it greets the user instead. Right? How does that work? Well, it's not magical. Right? You just, come on, you just use the command line argument. Right? So I know that the first command line argument is stored in $1, or sorry, it's stored in positional parameter 1. I can get its value using $1 or $brace1. You can always use the braces. Using the braces is always fine. Right? I recommend that when you access a variable, you just put it in braces because it's always legal. Right? And it stops these weird problems where if you forget them, something strange happens. Right? So I can just use the command line argument now inside my script. Right? What if it's missing? Right? So what happens if someone calls hello you without passing in a name or a string? Right? Well, again, it's not an error. Right? Bash just prints the empty string instead. Right? And now you get some funny output here. Right? So maybe you want to do some error checking in your script. Right? So maybe you want to check, is there actually a command line argument? Right? If not, maybe print an error or print in some default name. Right? So hello you or hello world or something like that. Right? But we'll see how to deal with, you need to know how to write an if statement before we do that. Okay, so what about that, remember we had that other program, we had that other script called make shell. So this one, right? So remember this little script, that creates a file called temp.sh, right? Inside that file, right? The first line, well, the first and only line of that file is that, right? So that's the interpreter directive that you put at the top of every bash script, right? And then it changes the permissions of that file so that the user has execute permission on it, right? But this always creates the program called temp.sh, right? It would be a lot more convenient if you could actually tell the program what's the name of the script. So we've got named sh.sh, right? So this is named shell.sh, right? Exact same thing, except now instead of temp.sh, we use the first command line argument as the name of the file, right? So now the user can specify what is the name of the file that's created. Right, so what's it called? Named, yes. So I don't know, some script.sh, right? And so now there's some, there's my, sorry. There's my newly created file, some script.sh, right? Notice that it's executable because it's shown in green on my computer, right? And it has that interpreter directive on the first line, right? Now there's a problem with this one in that, I think there's a problem. I haven't actually tried this yet. If you try to run this with no file name, I don't know what happens, so let's see what happens. Oh, there you go. So if you try to run it with no file name, now you get an error. Right? You get an ambiguous redirection. So in other words, you've redirected standard out of, sorry, you've redirected that string to nowhere. right? Because this is empty now, right? So that's the empty string if you don't pass in a command line argument, and apparently that's an error, right? Using change mod without a file name is also an error, right? So you actually get 2 errors in this script if you forget to pass in a command line argument, right? So this is a script that really does need some error checking to make it useful. All right, any questions about those examples there? Okay. The next notebook is the strings notebook. The variables notebook. So this is called variables, but this is actually a topic called parameter expansion in Bash. And sorry, this is a little slow on my laptop. There we go. Okay, so remember in Bash has these things called parameters, right? A variable is just a parameter that happens to start with a letter, right? Parameters store values, right? Okay. What can you name a Bash variable? So a Bash variable, you can include letters in the name, uppercase and lowercase. You can use numbers, and you can use an underscore, right? The name of the variable must begin with a letter or an underscore. Okay? You can't use symbols in a variable name, right? So that's also very similar to most other programming languages. Right? So in this course, I always use the convention that the variable names are a start in lowercase letter, unless it's a constant, right? If it's a multi-word name, I tend to use an underscore between the words, but I don't always. But that's just the convention I'm going to use, right? If you want to use a different convention, that's fine, right? So if you like camel case or something else, that's okay. Go ahead and do that. It's okay. There's no, unlike other programming languages, there's not really a fixed style convention in Bash. Okay, so Bash variables are untyped, right? And that's, sorry, so they're untyped because everything in Bash is just a string. Right, so that's the other thing you need to remember, right? Even if it looks like a number, as far as Bash concerns, it's just a string, right? If Bash needs to interpret that string as a number for some reason, like doing arithmetic, then it reinterprets it as a number, right? But in Bash, there really are no types, right? So everything's just a string as far as Bash is concerned. You might read online that there's a way to indicate that a variable does have a type. That's only kind of sort of true. Bash is free to ignore that if it wants, right? So there really aren't any types in Bash. Everything's just a string, right? Bash doesn't have any floating point arithmetic. If you need to do floating point arithmetic, you've got to find something else that can do it for you. Okay. So there's no special syntax when you declare a variable name, right? So because there's no types, declaring a Bash variable looks a lot like declaring a Python variable. Bash simply creates the variable for you when you first use it. And it doesn't matter when you first use it, right? So you can just write, for example, you can write this in Bash and it works. Right? So in Bash, you can write x equals y, and everything is fine, right? It automatically makes x. If there's no y, it automatically makes y and sets it to the empty string. Right? And now you've got 2 variables, x and y. X is the empty string, y is the empty string. That works. There's no error. There's no warning. Right? If you try that in Python, that doesn't work if y doesn't exist. Right? And of course, in Java, Java's got types, so that really doesn't work. Right? Now, when you create and assign a value to a variable, you cannot put spaces around the equal sign. Right? Another Bash weirdism. Right? So whenever you write an assignment statement, right, no space. Right? If you put the space in, Bash will complain. Right? And it's easy to check. Right? In your terminal, if I can find a terminal. Okay. So in my terminal, right, you can create variables on your terminal as well, from the command line as well. Right? So x equals 1 is fine. Right? No problem. Y space equals 2 is not fine, right? Why is it not fine? it says y command not found, right? So remember what bash is doing, right? So bash looks at a string or the input, right? And then wherever there's spaces, it separates that into separate tokens, right? So there's a space here, and there's a space here. So as far as bash is concerned, that line is y space equals space 2, right? Whenever bash sees something like that, it always thinks the first thing is command, right? So there's no command called y, right? And so you get this weird command not found, right? This is especially confusing if you happen to pick a variable name that does correspond to a command name. So ls equals 3 does not create a variable called ls, right? Instead, it tries to run the ls command listing the variable equals and the the file equals and the file 3, right? And of course, that doesn't work because I don't have a file called equals or 3 in this directory. Right? So you cannot use spaces around the assignment operator in bash, right? You can't put them on either side, right? So y equals 3 doesn't work either, right? Now it thinks 3 is a command, right? And that doesn't work. Okay, so there's some more examples here. So I've got a variable called b, right? It's equal to a string that's got a space in it. If I want to keep the space, I have to double quote it, right? If you're curious what happens, if you don't put the double quotes, just take them off and run the cell and see what happens. This is, okay, so this is using parameter substitution. So it's taking the value of variable A, the value of variable B, right? And smashing them together as two strings, right? So if I run this, I should run this in echo C, echo $C. So I have to echo $C, I can't echo C, right? Right, you get two sum string, which is the first string 2, and the second string sum string concatenated together, right? I have to echo $C here and not just C, right? If you echo C, you get C, right? That's why you need the $sign, right? Because again, as far as bash is concerned, everything's just a string, right? So if you try to access a variable name without putting the $sign in it, bash just considers that to be a string and prints out that string. All right, so if var is the name of a variable or parameter, doesn't matter, right? Then $var or $brace var is a reference to the value stored in the variable, right? So in other words, if you want the value of a variable, you got to put the $sign in front of it, right? Again, this is always correct, right? It's always correct. It will occasionally save you from considerable grief, right? So I encourage you to do that, but it's very tempting to write that, right? Because it's a lot easier to just leave the braces off. Oh, this thing here is called an expansion. That or that. So that's called parameter expansion, right? So when you see $ followed by a variable name or $brace, variable name brace, right? That's called parameter expansion. Parameter expansion takes the value of the parameter and substitutes that for whatever that is, highlighted in gray, right? So whatever $var gets replaced with the value of var, right? That's called parameter expansion. Okay, so reference is called parameter expansion or variable, also called variable expansion, right? Right? So in this case here, if you've got the string welcome user stored in the variable called MSG, right? Then you can echo or print the value of MSG by writing the $sign in front. Right? Again, if you leave the $sign off, you just get message, right? You just get the string instead of the variable. So you need the variable. You need the $sign to indicate that you want to do variable dereferencing. Oh, okay. So let's run this one again. Okay, so that one prints welcome user. Now it turns out there's a shell variable. Yes, sorry.
Do you have to have the quotation marks around the $MSG?
In this case, the answer is no.
Why?
So, well, let's see. Well, first of all, let's see if I'm right. So, okay, so yes, that works, right? So, when do you need quotes, right? So, quotes are there to suppress word breaking and everything, and a bunch of other substitutions, right? Here, it doesn't. So, the quotations do not suppress parameter substitution, right? So, in other words, if I do quote this, I'm still going to get, I'm still going to do parameter substitution for $message, right? Now, does word splitting matter here? The answer is no, right? Because I'm just printing out a string. So in this case, it doesn't matter. All right. Now, it turns out there's a variable called user, or a parameter, sorry, called user, that bash defines, right? So the parameter called user stores the current username. Stores the current username, right? So if I put $1 in front of user, I'm now going to get the value that's stored in the user variable. Right? So that's going to print welcome CISC220, right? Because the username on the virtual machine is CISC220. All right. Did I run that? Okay, so I think I ran that previous cell, right? Okay, so I have A, B, and C. So if I want to print out the values that are stored in A, B, and C, right, I can just echo $A, echo $B, echo $C. Oh, one more time, right? If I forget the $, you just get the strings, right? So if I forget the $, I don't get the value stored in the variable. I just get the whatever the string that happens to equal the variable's name is. Right? Okay, bash creates variables when they're first used. That's weird. I shouldn't have done that example, although that does work. Okay, so bash creates variables when they're first used, right? And it's not an error to attempt to use a variable that has not been created yet, right? So when bash sees an access to a variable that hasn't been created yet, it creates the variable, sets it to the empty string, and away you go, right? So this works. X equals $Y works, right? So normally when you assign a value to a variable, right, you want the value. When I write x equals, I shouldn't have written that, sorry. When I write x equals $Y, I want to get the value of whatever's stored in y and store that in x, right? Now, there is no y in this example, right? So here you just get the empty string. You don't get an error of any kind, right? When it prints something, it just prints the empty string, right? So you can also echo $x and $y in this case, and that also works, right? And now you get two empty strings. Right? So that's weird. You have to watch out for this. This is really easy. This is a really easy mistake to make if you have, especially if you have long, hard to spell variable names, right? Because it's very easy to make a mistake when you access the variable, right? If you spell the variable name wrong, bash automatically fills it with the empty string, right? It creates the variable, and then you get the empty string. So if you spell the variable name incorrectly, you don't get any indication that that's an error, right? So you have to watch. You have to be on the watch out for that. Okay, and so because bash will create a variable for you if you haven't used when you first use it, this is the reason why you sometimes need to use braces around the variable name, right? So there are situations where you must surround the variable name in braces instead of writing that, right, in order to get a correct result, right? So this script here, down here, right, it's going to try to, it's going to take in one argument, the name of a file, right, and it's going to try to make a backup copy of that file, right? So here, right, we're going to make a backup copy of the file. So the name of the backup is going to be the file name of the original file, underscore, dot back. Right? So if I have file 1, then the backup will be file1 underscore dot back. Right? So what's the name of my input file? Well, it's the first argument. Right? What's the name of my output file? So, well, it's just the value of the first argument. Right? So the value stored in followed by the underscore, followed by dot back, right? So how do I copy the file that's stored in in, or the file name? How do I copy a file name whose name is in to the file name whose name is out, right? Well, I just copy that, right? So CP, $in, $out, right? Now, I'll get to that in a second, right? And if you run it, right? Sorry, here. Okay, so I'm going to make a file called my file, right? And it has a space in it. I'm going to run my backup script, right? And then I'm going to list the contents of the directory. So let's see what happens when I run this thing. Probably shouldn't have ran it in that directory. Hang on. Did I tell you to switch that directory? Oh, I didn't tell you to switch that. Okay, never mind, it's fine. Okay, so there's my file. That's good. Now, if that script had worked correctly, there would be a file called myfile_back, right? But what is there? Well, there's a .back, right? Is there something else that's funny here? Any other funny file names here? It looks like there's just a .back. Okay. I thought there would be another funny one in here. All right. So, oh no, there is just a .back, right? Notice that there is no myfile_.back. Right? There's my file. No myfile_.back. There is a .back, right? So what's gone on here? Right? So when you go back and read this, right? You've got this variable called in, right? Here, if you just read this casually, right? There's your dereference of the variable called in, right? So there's my parameter substitution, or at least that's what it looks like, right? But what you have to remember is that the underscore is a legal character in a file name, in a variable name. So what's happened here is that gets used as a variable name, right? So the variable is $in underscore, right? There is no $in underscore. So what does bash do? It substitutes it creates the variable it creates the variable in underscore, sets it to the empty string, and then uses its value, right? So out is the empty string .back, right? And that's why when you create the backup file is just .back, right? It's because that $in, right, followed by the underscore, looks like a variable name, right? The actual variable name is just in. So in this case, you have to surround, well, one way to fix the problem is to surround the in using braces, right? So now if you save, I have to edit the file to save that, sorry. I think I have the correct version of it somewhere. Yes. So the correct version of the file is called backup.sh, right? It actually surrounds in with braces. If I run that, now you see that there is a myfile.back, right? And if you want to see the script that actually does it, it's called, oh, where'd it go? Oh, wait, we're on the wrong directory, sorry. Okay, so we're in variables. Right? And so there you can see that I've surrounded the in with braces. Right? And so that's why I said that whenever you want to do a variable dereference, right, it's always safe to surround the name of the variable inside braces. Okay, let's take a look at the. All right, so we saw some expansions in the previous lecture, right? So we saw brace expansion, we saw arithmetic expansions, and some other things. You can take an expansion and store the result in a variable. So there's our brace expansion, right? So that produces this 3 strings, the good, the bad, the ugly, right? There's another brace expansion, right? That produces the string 2020 space 2023, 2026, 2029. Tilde expansion, right? That produces the name of the home directory for the current user, right? File name expansion, right? That lists all the files, that matches all the files that end in .ipynb, right? There's no reason why you can't take these expansions and store them in a variable, right? Because they're just strings, right? The expansions are just strings. So if I run this, right, not surprisingly, you get that output there, right? If I want to, right, I can take those expansions, store them in variables, and then later on I can use the value of those variables, right? So here I'm going to take that expansion, store it in the string movie, right? I'm going to take this expansion, store it in the string year, in the variable years, right? I can store whatever the value of tilde is in my variable called homedir, right? And I can store the list of notebook files in this variable called notebooks, right? And when you run that, right? Right? So here I'm just accessing or dereferencing the variable, right? So, oh, that's interesting. That's not that should not have happened. Oh, that's fascinating. Why did that happen? Hang on, let me take a look. That's not what I was expecting to happen. Hang on. No, that shouldn't have happened. That should have worked. No, that should have worked. That should have been fine. What's going on? That should not have stored that string there. All right, I'll find out what's going on with this example and explain what's happening next day. You should get another assignment coming out today or tomorrow. Probably tomorrow, the way things are working out.